Hello students, I am Lokesh and in this video I am going to explain the concept of number system. Okay, so without wasting any time, let's just start the topic number system. And the topic is about the 9th standard students. So this will helpful for all the 9th class student actually. So let's just start. You all have studied in your previous classes about the number line and about the various types of numbers. Okay, so let's just recall it. This is your number line. You all know about the number line, how can it be made. Okay, so this is a number line and in the middle it is 0. On the right direction it is 1, 2, 3, 4, 5 and 6. -1, -2, -3, -4, -5 and -6. This number line it doesn't stop here. It goes further in the right direction and in the left direction, but for our convenience I made it only for this. Okay, so let's just start. So this is a number line. Okay, let's just assume that you are standing here. Okay, you are standing here. You are a person and you are standing here. You are standing on 0. Okay, you are standing on 0 and you want to walk. So you think that let's just walk on the right direction. Okay, you just think that you should walk on the right direction. So when you and also you have a bag in your hand. You have a bag in your hand. Okay, you have a bag in your hand and you want to walk on the right direction. So while moving towards the right direction, what you observe? You observe that there are the numbers. There are all the numbers which are positive numbers. Okay, these are the numbers which are of positive sign. So you should collect these numbers on your bag. Okay, so when you collect these numbers on your bag, so what numbers will you get on your bag? That is the numbers like 1, 2, 3, 4, 5, 6, 7, and there are many positive numbers, as this is a number line. Okay, this is a number line and you all know that a line is imaginary. It can be stopped anywhere. Okay, it can be stopped where we think. It goes on and on. So what numbers you collected while going on the right direction? These are 1, 2, 3, 4, 5, 6, 7 and all the positive numbers you collected here. Okay, and all the positive numbers. So what these numbers called? These numbers called the set of natural numbers. These are the set of natural numbers, and we can say it as the set of natural numbers can be represented as n. It is represented as n. Okay, now you think to collect this 02 in your bag. Okay, you think to collect this 02 in your bag. So you move back and collect this 0. So now what type of numbers you have in your bag? You have 0, 1, 2, 3, 4, 5, 6, 7 and so on numbers in your bag. So what does these numbers called? These numbers called the set of whole numbers. These numbers called the set of whole numbers. Okay, and these whole numbers are represented by an alphabet which is capital W. Okay, now an idea comes in your mind. You thought that let's just collect all the negative numbers too. Let's just walk towards a left direction and collect all the numbers which will come in my way. Okay, so you move towards the left direction and collect all the numbers in your bag. Okay, so what type of numbers now you have in your bag? You have the numbers called 0, 1, 2, 3, 4, 5, 6, 7 and so on. These are already present in your bag and included with -6, -5, -4, -3, -2, -1. These all numbers you have collected in your bag, and these collection of numbers are called integers. Okay, these are what? These are the integers. So, and this set of integers, this set of numbers are represented by the symbol called Z. So why Z? Okay, why Z? Because natural numbers are represented by the symbol and whole numbers are represented by the symbol W. So why integers are represented by Z? So the reason is Z letter comes from the German word. Z letter comes from the German word which is called Zehlen. Okay, the word is Zehlen. Zehlen is a German word. Zehlen is a German word. Okay, Zehlen is a German word which means to count, which means to count. So from here this Z alphabet comes as a set of integers. Okay, now what you guys thought, what you students thought, that you have collected 0 as well, you have collected all the positive numbers and also all the negative numbers. So what do you think, that this number line becomes blank? No dear students, this number line doesn't becomes blank, because you all know that in between two numbers, or we can say in between 0 and 1, there are infinitely many numbers exist. Okay, infinitely many numbers exist. If we talk about any scale, if you have scale in your pencil box, so what will you observe? There is a number that is 0 and there is 1. So in between 0 and 1 there are many small 10 lines exist. Okay, so this explains that in between 0 and 1 there are also exist the other numbers. Okay, so what does the numbers which exist in between these two lines, these two numbers? So other set of number is your rational number. Okay, in the 8th class you have studied about the rational number deeply, that what is rational number. Okay, so here rational number, what is rational number? So rational number, any number, we can say any number as R, any number R can be called as a rational number when it can be written in the form of P upon Q, where these now the thing which I am going to write are the important conditions for being a rational number, where P and Q both should be integers. P and Q both should be integers, and Q should not be equal to 0. So these are the two conditions for being any number as a rational number. Okay, so any number is called rational number when it can be written in the form of P upon Q, where P and Q both should be integers and Q is not equal to 0. Okay, so now for example is 1 upon 2, or we can say 3 upon 4, or minus 91 upon 200, or minus 6, or minus 5, or 4, etc. These all numbers are called rational number. Okay, why these all numbers are called rational number? Because let's just take 1 upon 2. So 1 and 2 both are what? Both are integers. Okay, both are integers, and this 2 is not equal to 0, so we can say that 1 upon 2 is a rational number. Okay, 3 upon 4, here 3 and 4 both are integers, and this 4 is not equal to 0, so we can say that 3 upon 4 is also a rational number. In this example, minus 91 upon 200, this minus 91 and 200 both are integers, and 200 is not equal to 0, so we can say that minus 91 upon 200 is a rational number. In this case, minus 6 is a rational number. Okay, if we take it independently, so what is it? It is a type of integer actually, it is a type of integer. Why we observe this as a rational number? Because minus 6 can also be written in the form of minus 6 upon 1, where minus 6 and 1 both are integers. Okay, minus 6 and 1 both are integers, and 1 is not equal to 0. So we can say that minus 6, which we called it as an integer, is also known as a rational number. Okay, similarly in the minus 5 and also 4, which we called it as natural number, so natural number is also a rational number. Okay, so by seeing these examples, what conclusion we made? What conclusion we made? We made that all the natural numbers, all the whole numbers, as well as all the integers are known as rational numbers, isn't it? All the natural numbers, all the whole numbers, even 0 is also a rational number. Okay, even 0 is also a rational number, because 0 we can write 0 it as 0 upon 1, where 0 and 1 both are integers. Okay, 0 and 1 both are integers, and 1 is not equal to 0, so 0 is also a type of rational number. Okay, so the conclusion we made it as all the natural numbers, whole numbers, and integers are known as rational numbers. Okay, now let's just move forward. There are another set of numbers, and also wait, rational number can be represented by a symbol that is called Q. Okay, now let's just move forward. There are another set of number, that is irrational number. Okay, that is irrational numbers. Yes, irrational numbers. So what are irrational numbers? If we ask to anybody that what are irrational number, so the simple definition of irrational number is that any number which is not rational is called irrational number. Any number which is not rational is called irrational number. Okay, or we can say that any number which cannot be written in the form of P upon Q, any number which cannot be written in the form of P upon Q, so these numbers are known as irrational numbers. Okay, any numbers which cannot be written in the form of P upon Q, so these numbers are known as irrational number. So example of irrational numbers are what? Examples are root 2, root 3, root 5, root 7, root 6, root 15, pi, etc. These all can be expressed as an irrational number because this cannot be written in the form of P upon Q. If we see that you guys have a doubt that root 2 can be written in the form of root 2 upon 1, so why this root 2 upon 1 cannot be a rational number? Dear students, 1 is an integer, but root 2 cannot be expressed as an integer, so that is why root 2 is not a rational number. 1 can be explained as a integer, but root 2 is not an integer, right? So all in all, root 2 is not a rational number, so it comes under irrational numbers. Okay, now there are another set of numbers which is called real numbers. What are these? Are the real numbers. And so now what are these real numbers called? These are nothing the collection of all the numbers which we have studied before, like the collection of natural number, the collection of whole number, the collection of rational number. Okay, the collection of all the numbers is called real numbers. Okay, so real numbers are what? Real numbers are those numbers which are the collection of natural numbers, whole numbers, rational numbers, integers, and also irrational number. Okay, so real number is a collection of all the numbers which we have studied before. All right, now as I have discussed that real number is a collection of all the numbers which we have studied before, so this number line, okay, this number line, the numbers on this number line are the real numbers. Okay, the number on in this number line is the number exists in this number line is a real number. All the numbers are the real number because -6 is also a real number, -5 is also a real number, the number exists between -6 and -5 here is also a real number. So every number is a real number in this number line, so this number line can also be called as a real number line. Okay, so the number line can also be called as a real number line. All right, so from here a conclusion is made, that is, the real number is, every real number is represented by a unique point on the number line. This is an important conclusion which comes out, that is, every real number is represented by a unique point. Okay, every real number is represented by a unique point on the number line. So what does this mean? Every real number is represented by a unique point on the number line. Where is a number line? This is a number line. This is a number line, and these are all the unique points. These are all the unique points. This is a unique point. The number exists in between this, to say here, this is also a unique point. So every number exists in this number line. Every point exists in between this number line is represented by a real number. Okay, so this conclusion means that every real number can be expressed as a unique point on the number line. Okay, so let's just solve one question which is not a new question for all of you. You all have practiced on at the previous class. The question is, find 6 rational number between 2 and 3. You all have practiced this type of question. Find 6 rational number between 2 and 3. Okay, so how can we solve this question? So listen, we want how many rational numbers we want? We want 6 rational number. Okay, we want 6 rational number. So we write this 2 and 3 in the form of numerator and denominator, where we put denominator as 7. Okay, we want 6 rational number, right? We want 6 rational number in between this. So we write 2 and 3 in the form of what? In the form of numerator upon denominator, where we put the denominator of this as 7. Okay, 2 can be written as 2 upon 1 and 3 can be written as 3 upon 1. So we have to make one as a one denominator as 7. So 1 into 7. So in the same way, we multiply above as 2 into 7, so it becomes 14 upon 7. And we also convert 3 upon 1 as like above. So 1 into 7 and 3 into 7, it will comes 21 upon 7. Okay, so 2 and 3 number can be written in the form of 14 upon 7 and 21 upon 7. So we can easily find out the 6 rational number in between 2 and 3. Okay, so 14 upon 7, and here it is 21 upon 7. So the 6 rational number in between this are 15 upon 7, 16 upon 7, 17 upon 7, 18 upon 7, 19 upon 7, and at last 20 upon 7. So these numbers which exist in between 14 upon 7 and 21 upon 7, these are the 6 rational number which we want in our answer. Okay, so these are the 6 rational number which exist between 14 upon 7 and 21 upon 7, and 14 upon 7 and 21 upon 7 are what? These are our 2 and 3. So 2 and 3 के बीच में we have 6 rational number. What are these? These are 15 upon 7, 16 upon 7, 17 upon 7, 18 upon 7, 19 upon 7, and at last 20 upon 7. Okay, so that's all for today. In the next video we shall discuss about the irrational number. Okay, we shall discuss about the irrational number, the location of irrational number on the integers line, and so on. So that's all for today. I hope you like this video. So if you like this video, please like, share and subscribe. Okay, thank you.